The indeterminate form of 0 over 0. Recall our problem from earlier. We had f of x is equal to x minus 3, and the limit of f of x as x approaches 3 was 0. And the function g of x was equal to x squared minus 6x plus 9, all divided by x minus 3. And the limit of g of x as x approaches 3 was also 0. The first one worked out well with direct substitution, but what about the second one, where g of x is equal to x squared minus 6x plus 9, all divided by x minus 3? Can you use substitution to evaluate the limit? Do you need a graph to solve this? Take a moment to pause this video and think about it, and when you're done, unpause it. In this case, substitution will not work. We can clearly see with direct substitution, if we just substitute in there, we get 3 squared minus 6 times 3 plus 9, which is going to be 9 minus 18, which is negative 9 plus 9. That's 0. And 3 minus 3 is also 0. And that's not equal to 0. However, we don't need a graph to find this limit either. From the result above, we see that we get the result of 0 over 0. In calculus, this is called an indeterminate form. It means when we cannot determine the answer due to the form of the problem. In the case of rational functions, the indeterminate form 0 over 0 as x approaches a occurs when analytical functions have a hole in their graph. And recall from algebra that when we get 0 divided by 0, that means the numerator and denominator share a factor. So how do we undo the indeterminate form? Take a moment to pause this video and think about it, and when you're done, unpause it. The technique that we're going to use can be referred to as factor, cancel, and then substitute. So first we have our two polynomial expressions in our rational function, and we can factor the numerator to be x minus 3 times x minus 3, and then the denominator is still x minus 3. We can cancel out the common factor of x minus 3, and then we can substitute the value that x is approaching directly into the simplified function and evaluate it. So we would get 3 minus 3, which equals 0. Notice we get the answer predicted by the graph that was shown earlier, because we're approaching 3 from both the left and the right, and when we do that, we are approaching a y value of 0. So it does provide us with the same solution that we had found earlier when we used a graph. Let's try to evaluate this limit. We're doing the limit of the rational function x squared plus 4x minus 21 divided by the quantity x plus 7 as x approaches negative 7. Well, substitution fails here when you try to substitute negative 7 in, and we can show that because we would have negative 7 squared plus 4 times negative 7 minus 21, and then divided by negative 7 plus 7. We know the denominator is going to be 0. If we evaluate the numerator, we're going to have 49 minus 28 minus 21. Well, that equals 0 also. So we have an indeterminate form. That means that we can factor. So let's actually factor this rational function. We have x squared plus 4x minus 21 in the numerator, and the factors of negative 21 that add up to positive 4 are positive 7 and negative 3. So we can rewrite the numerator as x plus 7 times x minus 3, and the denominator stays the same with x plus 7. Well, we have two common factors of x plus 7 that we can cancel out in both the numerator and denominator. And And that will leave us with the limit of x minus 3 as x approaches -7. And now we can use substitution to find this limit. So we have the limit of x minus 3 as x approaches -7 is equal to -7 minus 3, which is -10. Let's try to evaluate this limit. The limit of x squared minus 4 divided by the quantity x minus 2 as x approaches 2. Substitution fails here when you try to plug 2 into the denominator. We end up getting 0. Let's also double check what happens when we plug 2 into the numerator. We would get 2 squared minus 4, and again we'll get 2 minus 2. We know that the bottom, or the denominator, is going to be 0, but we will also get 0 in the numerator, so we have another indeterminate form. And since this is a rational function, and we found out that we would get 0 over 0, we can factor and simplify. So the factors of -4 that add up to 0 are +2 and -2, so we would have x plus 2 times x minus 2 in the numerator, and the denominator remains the same, x minus 2. Notice we have a common factor of x minus 2 in both the numerator and denominator, so we can cancel them out. And then we have the limit of x plus 2 as x approaches 2. Now we can use substitution to find the limit. So we can substitute 2 in for x in the resulting expression that we have here. So we have the limit of x plus 2 as x approaches 2 is equal to 2 plus 2, which equals 4.